Once you've chosen a geographical context and a location, and you've come up with your question and your sub-questions, the next thing you need to think about is your methodology, or your way in which you're going to collect your data. Whatever your location or geographical context, you will have a population or subject area from which you need to collect data. Due to constraints such as time and space, you have to select which data you collect. This needs to be selected so that the data you collect is representative of the whole area or population. To ensure that this is done correctly, we use sampling techniques. Sampling is a process of measuring a small number of sites or people in order to obtain a perspective of all sites and all people. There are three main sampling techniques: random, systematic, and stratified. The technique you use depends on the type of data you need, but the aim of all three types is to ensure your data is representative of the whole population and to reduce bias. A biased sample means that some elements of the population or location are less likely to be included than others. I'm now going to go through the three main types of sampling technique. Random sampling is used when you want to collect data from the entire population or location. In random sampling, each member of the population or location is equally likely to be included in the sample. It can be used for any type of data, such as choosing people to ask questionnaires, locations for measuring things such as wind speed, or sites for counting species diversity. It links to a question which is asked about the entire population of an area or an entire site, where it does not require you to cover any particular section of the population or site. This is how you undertake random sampling. You need to choose a sample area that is a small selected area of your larger site or the whole area. You can pick locations within that area by generating random coordinates. These random locations are where you undertake your data collection. This is how you undertake random sampling.
In your sample area, pick a random number. That is the location on one axis or tape. Next, pick up a second random number. This is the location on the second tape or axis. Where these two locations meet, this is your sample site, where you undertake your data collection. Repeat this process to generate the required number of samples randomly within your sample area.
The advantages of random sampling are that it's the least biased of all the sampling techniques. There is no subjectivity, and each member of the total population has an equal chance of being selected. It can also be used with large populations. The disadvantages of random sampling are that it can lead to clustering with poor representation or coverage of the areas. Access may not be possible, where parts of the population may not be available for questionnaire or won't take part, and it's also time consuming. Stratified sampling is when your population or your location naturally divides into subsets. So for example, here we're in a sand dune system. If you want to make sure you've got a representation of all the different sub-areas in your location, you divide them into those subsets and you undertake sampling within those sets. Now, it's usually used in combination with another type of sampling. So for example, random sampling. So if we wanted to know what the species diversity was in the foredunes, we would undertake data collecting in the foredunes there, and that would be our subset, our first stratified area. Within that, however, we would lay out our tape measures and undertake random sampling so that we would be unbiased in our collection of our data. We would then compare that to another of our subsets, which might be our grey dunes here. So again, you'd collect using random sampling within this subset at location, within our grey dunes. Then for a third comparison in your location, you would take another set of data in your third subset, which would be your dune meadow. The advantages of stratified sampling is that it can generate results which are representative of the whole population. It's very flexible, and comparisons can be made between the subsets. It avoids bias and ensures all areas are covered. The disadvantages are that you need to know the proportions of your subsets for it to be representative, requires a good knowledge of the local area or the population, access may become a problem, It may be difficult to know exactly how to divide your subsets, and it might be hard to stratify if you're using things like questionnaires and you don't have the subsets that you require. Systematic sampling is sampling that's done over regular intervals along a line. It could be at regular distances from a location. It could be every 12th house if you're measuring houses, or it could be every 5th person, or it could be time intervals. If you're collecting systematically along a transect, then you can collect some continuous data. Now that's very important, that form of data, if you're going to undertake some kind of correlation. If you're looking at how two variables vary with each other, then a systematic way of sampling is the most appropriate. It also means that you can make sure that every part of that area is going to be counted, but you do need to make sure the gaps between your sample sites are going to be appropriate, because you can bring in a bit of bias. It's a really good way of accurately depicting any continuous change in a variable. So if you're moving away from a location and you want to see how things change over distance, then you need to undertake systematic sampling. Main advantages of systematic sampling is it's very quick and it's easy. You get complete coverage of all the distances from one location to another. It avoids clustering of data, and it's an accurate way of looking at continuous variation from one set point. The main disadvantages are that you may miss out key sites if the spaces between your sample locations are too large. You may inadvertently be biased in choosing your transect or your line. It is more biased than the random because every location has not got an equal chance of being chosen. Therefore, you can have over or underrepresentation of some patterns. If you get to your sample location and you find that it's not possible to undertake the technique you were planning, either due to access issues or a lack of participants, then you can undertake pragmatic or opportunistic sampling. This is when the sample site is adjusted due to access or safety issues, or when participants are selected so that they are included in the data. The advantages of pragmatic sampling is that it makes the data collection safe. It's also more convenient and less time-consuming. The disadvantages of pragmatic sampling is you may not be truly representative of the population, and it's not really a fair sample because you are being biased in allocating your location or your participants, and you can't make valid statistical references. So let's recap. Random sampling. Every location has an equal chance of being chosen, however you can get clustering. Stratified sampling. Dividing your area or dividing your population into subsets and undertaking another type of sampling within those subsets. Systematic sampling, going along a transect or systematically measuring at intervals along a line. Good for looking for continuous data and looking for a correlation between variables. Pragmatic sampling is when you adjust your sampling technique based on safety issues or making it more realistic when you actually get out on the field. Now, head back to the resource and we'll test your understanding of your sampling techniques by seeing if you can answer what sampling technique is the most appropriate for these other inquiry questions.